Analyze the balanced chemical equation. The reaction stoichiometry is given as 5H2O2 plus 2MnO4 to the power negative plus 6H to the power plus gives 2 millinewtons to the power 2 plus 8H2O plus 5O2 from the coefficients. We can see that for every 2 moles of MnO4 to the power negative that are consumed, 5 moles of O2 are produced. Relate the rates of chemical species to overall reaction rate. The rate of a reaction can be expressed using the change in concentration of any reactant or product over time, divided by its stoichiometric coefficient, with reactants being negative to represent disappearance and products being positive to represent appearance. Reaction rate equals 1 over 2 delta MnO4 to the power negative over delta T equals plus 1 over 5 delta O2 over delta T. Set up the relative rate relationship. To find the rate of disappearance of permanganate, delta MnO4 to the power negative over delta T, relative to the rate of appearance of oxygen, plus delta O2 over delta T. Isolate the permanganate term by multiplying both sides of the rate equality by 2. Rate of disappearance of MnO4 to the power negative equals 2 over 5 times rate of appearance of O2. Substitute the given values. Plug in the rate of appearance of O2, which is 1.0 times 10 to the power minus 3 moles slash L times S. Rate of disappearance of MnO4 to the power negative equals 2 over 5 times 1.0 times 10 to the power minus 3 moles slash L times S. Perform the final calculation. Rate of disappearance of MnO4 to the power negative equals 0.40 times 1.0 times 10 to the power minus 3 moles slash L times S. Equals math 4.0 times 10 to the power minus 4 moles slash L times S. This matches option D. The correct answer is option D, 4.0 by 10 to the power minus 4 moles slash LS.